Here's the plan. I'll make a tool and send it as a gift to another YouTube machinist. They'll make something and send it to someone else, and eventually someone will make something and send it to me. We'll call it... Welcome back to Cloud 42. I'm James, and welcome to Toolroom Takeover 2025. A few months ago, Brandon at Inheritance Machining reached out to me to see if I was interested in a YouTube machinist gift exchange. I said, of course, I'm always happy to help out a smaller creator. There are a bunch of awesome channels involved in this project, including Alex Steele, NBR Works, Blondie Hacks, Jonesy Makes, Not an Engineer, and Eric with a K, who organized this whole thing. We drew names, and I will be making something for Mike at Chronova Engineering, and I should be receiving something from Uri Tuchman, so stick around to the end of the video to see that. Before this project, I wasn't actually familiar with Chronova Engineering, and when I started watching their videos, I have to admit I panicked a little bit. The stuff they make on the channel is just amazing. Mike's currently making a watch movement entirely from scratch, and he's got another video where he made a miniature steam engine that he had to film with a microscope. If you haven't already, you should definitely check them out. So what do you make for someone like that? I have no idea, so I just decided to make something that I want for myself, a precision taper gauge. I'll make two, and we'll both win. If you haven't used one, a taper gauge is a wedge-shaped tool with a scale on it, but instead of measuring the length, the scale reads out the thickness of the wedge at that point. You slide it into a gap until it stops and read the width of the gap off of the scale. I think it'll be a fun project, and it should give me a chance to use most of the tools in the shop. I'm going to make the taper gauge out of A2 tool steel. I bought it in a 1/4 inch by 3/4 inch flat bar, which should save me a bunch of time because all I have to do is cut it to length, make a nice rounded handle on one end, and then taper it. There are lots of ways to shape the handle end, and I actually dimensioned it so it would be easy to do with a 3/4 inch end mill and a rotary table. But if you've been following the channel, you know I've been converting a Precision Matthews benchtop mill to CNC. There's a whole playlist on the channel if you want to see that. And it's just close enough to done to be usable, which we all know is the most dangerous part of any project. So let's use it. Because the part is longer than the 4-inch vise I have on the machine, I can machine both ends in a single setup. The material's pre-ground, so I won't worry about machining the sides. The material is slightly oversized, but the width doesn't really matter, so I won't bother with it. The end mill I'm using is a 1/4 inch variable flute coated end mill from Lakeshore Carbide. I asked Grok to recommend feeds and speeds for this particular end mill in a PM728 CNC conversion mill, and the numbers it came up with looked pretty plausible, so I just ran them, and they are working beautifully. This is actually the first real machining operation I've done on this machine post CNC conversion, and so far I'm impressed. It's significantly more rigid than the Grizzly I used to have, and the whole system with the belt-driven spindle and the servos on the ball screws is a lot quieter. I programmed a spring pass, but I really don't think it's needed. All it's really doing is just smearing up the beautiful surface finish I got from the final contour. I had enough material to cut 5 blanks, and I went ahead and CNC machined them all. I need one part for setup, and I want 2 good ones when I'm done, but the cycle time is only a couple of minutes, so machining the other 2 seems like something that a smart person would do. I don't think there's much residual stress in the material, but I don't really know, so I think the safest thing to do is to remove an equal amount of material from each side. If I remove it all from one side, it might turn into a banana while I'm machining it or later during heat treatment, so I think it's better to just play it safe. I took the taper angle from the Fusion model, and I asked Grok to calculate the correct gauge block stack-ups for my 5-inch sign plate. Half the angle for the first side and the full angle for the second side. I was pretty frustrated with the AI for a while because it kept recommending a stack up that was too tall, and then suggesting that I just subtract 200 thousandths, which is not a thing you can do with gauge blocks. Except that actually it turns out you can. I realized later that my sign plate has a smaller diameter tip on the end of each roll that actually subtracts 200 thousandths, so you can set up lower angles with it. I'm doing the rough milling on a magnetic chuck because it was the only way I could think of to hold the parts and mill the entire surface without machining a sacrificial fixture of some kind. The tip is so thin that I was afraid it would flex if I left it sticking out of the top or the side of the mill vise. The magnetic chuck was just barely secure enough to make this work. It held the parts in place and it supported the thin tip, but it was definitely sketchy. I did the math and determined that a sharp carbide cutter would have the lowest tool pressure of anything that I had, and there wasn't much difference between a 1/4 inch and a 1/2 inch end mill, so I opted for the bigger cutter just to make the job go faster. Using a roughing end mill was optimistic, even though I packed the parts in on the vise with steel sheet material to try to keep them from sliding around. They really wanted to move, and I had to take lots of light passes on each side, making this easily the most time-consuming part of the project. I think if I had to do this again, I would make some 3D printed sacrificial fences to bear the side loads and allow me to push the cuts harder. You may consider that foreshadowing. Right off the mill, the surface finish looks great, and the parts look pretty straight, at least as far as I can tell. They really didn't move during the milling operation. You can still see the flat facet at the handle end of each part, which means there should be about 15 thousandths of an inch left for grinding after heat treating. Now, I only rough milled 3 of the 5 blanks. I'll keep the other 2 around just in case, but I don't really think it's worth the time at this point because things are going so well. You might also consider that foreshadowing if you like. My heat treating furnace doesn't have a controlled atmosphere, so I have to wrap the parts in stainless steel foil to prevent them from oxidizing. I'll also slip a small piece of paper into each packet. What's written on the paper doesn't matter very much. What's more important is that the paper will burn and consume any oxygen present inside the packet before it gets hot enough to oxidize the steel. I'll also wrap up an extra piece of the same material as a hardness testing sample, so I don't have to make hardness testing divots in the real parts. These all go into the Hot Shot 360 oven standing vertically in a ceramic knife rack to try to minimize any forces that might cause them to warp. I did my best to shape the foil packet with a little flat edge on the bottom so they stand up squarely. The oven is programmed to preheat the material slowly in stages before taking it up to 1750 degrees Fahrenheit and holding for 30 minutes. The total cycle is about 5 hours, and then the parts come out of the oven and onto another ceramic rack to cool. A2 tool steel is air quenched, and for thin sections like this, cooling in the foil packet works just fine. It's also way easier and safer than trying to open the hot foil packets. After cooling to room temperature, the test sample measures around 61 Rockwell C, so the heat treatment worked. But the parts are also very brittle in this state, so they go directly into an oven to temper at 260 degrees Celsius for a couple of hours, and then cool slowly to room temperature. After 2 full tempering cycles, the test sample now measures around 57 Rockwell C, which is just about where we want it. That's hard enough to be durable, it's now a lot less brittle, and it should be somewhere close to the peak of the toughness curve for A2. The heat treating is definitely worth it if we want to make a durable tool that will last, but the multiple heating and cooling cycles take a lot of time. It definitely ended up being the most time-consuming part of the project. Inspecting the parts on the surface plate, they all came out bowed less than 9 thousandths of an inch. One of them was only 3 thousandths. That's less than the amount of material we still need to grind off to reach dimensions, so I don't think it's worth trying to straighten them first before grinding. To grind, I'll move the sign plate setup I used for milling over to the grinder. Since the parts are already rough tapered, I only need one angle. I can grind both sides without changing the setup. If you've been following the channel, you know this is a 6x18 manual surface grinder that I converted to CNC. I have a playlist with that video series if you haven't seen it, and just like the CNC mill, it's barely done enough to use, so more videos will be coming as I encounter things I want to do with it. If I just put the warped parts down on the magnetic chuck, the magnet will pull them down flat, which will allow me to make them pretty, but as soon as the magnet releases, they'll just spring back to their warped shape, which isn't what I want. So I need to somehow hold the parts with the bow still in them so I can grind one side flat in the relaxed state. Shimming with brass shim stock only partially works. With the parts frown side down on the chuck and the proper thickness of brass shim under the center, it will hold it at the right height, but the magnet still pulls the part down in places that aren't fully supported, and it just ends up grinding the part into kind of a W shape. And then when I flip it over to grind the other side, this causes the tip to rise up and bite into the wheel. Ask me how I know. So I asked some smart friends and learned about the paper towel trick. If you saturate a strip of paper towel with coolant and put it under the part with the frown side down, it will support the center of the part so the magnet doesn't fully flatten it out. I have no idea why this works, but it does. It holds the part securely, and the grinder makes contact with the middle of the bow first, and it's pretty easy to grind one side of the part flat. And then with one side cleaned up and flat, I can flip it over, placing the now flat side down on the mag chuck and grind directly to dimension. Now I say that like it's easy, but it's complicated. I only have mist coolant on this grinder, and it is easy to build up heat in the part. The slightest bit of heat in a thin part like this causes it to warp, causes the thin tip to lift up off the chuck and bite into the wheel. The only way I was able to get this to work was to make the coolant mist very, very wet and to go very slowly. For a lot of the finish grinding, I only took 1/10,000th of an inch or even half a tenth or 50 millionths of an inch per pass. With flood coolant, I could probably go faster, but with the setup I have on the machine today, it took a long time to get 3 parts ground flat and to dimension. This easily ended up being the most time-consuming part of the project. For my first real grinding project on the machine and my first experience with A2 tool steel, I think it turned out okay. You can see that my setup part has some burn marks from overheating, but the other two that I ground more slowly turned out great. There's a little bit of residual warping in the parts, but it's easy to take that out by manually straightening in a copper jaw vise. The first time I tried this, I was afraid the part would snap, but they're pretty tough and springy. You have to push them past their elastic limit to straighten them, and it takes a little bit of practice, but it turns out not to be hard at all. The grinding, of course, left sharp edges, but I can soften those gently with a unitized silicon carbide wheel or a Scotch-Brite wheel. I also did this earlier to deburr after milling, but this pass is just to soften the edges so they feel nice in the hand, being very careful not to haze the nice, pretty, freshly ground surfaces. A silicon carbide impregnated buffing wheel on the NSK pencil grinder easily takes the oxide layer off the rounded edges that I couldn't reach on the buffer. These surfaces are still as is right off the CNC mill, and I actually think they look better than the surfaces that were ground on the surface grinder. One side of the gauge will be marked with millimeters and the other side with inches. I drew the scales in Fusion, and this turned out to be harder than expected. Fusion sketches work great when they're simple, but when you start assembling patterns with hundreds of elements, it bogs down quickly and often crashes while recomputing. This easily ended up being the most time-consuming part of the project. I double-checked the taper by traversing an indicator over the final ground surface using the DRO on the mill to verify that the thickness varies by the correct amount over the length of the scale. I was planning to scale the artwork to account for errors in the grind, but the sign plate did its job, and it was accurate at least to the limits of what I can measure and far in excess of what you'll be able to see with your eyes when actually using it. I asked Grok to recommend settings for a 20-watt fiber laser to get a clean, black, slightly recessed mark in heat-treated A2 tool steel. It suggested some settings, I put them into light burn, and what you're seeing is my first and only attempt. The test part looked great, so there's no need to experiment. The laser marking process raises some brown oxides around the cut, and you can see that, but they wipe off easily, leaving a nice, clean engraving. In addition to the scales, I'll also add a Chronova Engineering logo on one side and my logo on the other, and as long as we're here, we might as well mark these as a part of Toolroom Takeover 2025. That should raise their value on the collector's market someday. These are going to the UK where things actually rust, so I'll give them a coating of BoShield T9, wipe that down, and let it dry. Not only does it prevent rust, but it settles into the oxidized laser and makes the laser markings really pop. I really could not ask for a better end result. This is exactly what I imagined when I was planning the project, but of course, it's always way better when you can hold the finished part in your hand. I'm happy with these, and I would be proud to give them to somebody else, which is of course exactly what they're for. It's nice that they're pretty, but they also need to be accurate. Now, I already did some testing off camera just to assuage my crippling anxiety, and to my delight, they're pretty good. Just for fun though, let's do a blind test. I'll turn off this caliper, set it randomly to some unknown dimension, lock it, and we'll measure it with the taper gauge. Sliding the gauge in until it stops, that looks to me like about 3.35 millimeters. Let's turn on the caliper, and it agrees. I'm really glad that worked. Is this a precision measuring tool? Not really, but also yes. This package has to go across the pond, and I want it to arrive looking exactly like it does now. So I'll wrap it in VCI paper, make a 3D printed case to keep it from cutting its way out of the shipping box, and seal it in a bag with a desiccant pack. I shipped the package using FedEx because I wanted to be really sure it got there in time, and it should have taken 2 days. It's now been 4 weeks. FedEx says they didn't lose it, they intercepted it so that their fraud department could validate my shipper account. That process took 3 days, after which they told me they would release the package, and then they went dark. I have called and spoken to a half a dozen different people in different departments. I have the name, email address, and direct extension of the person who's supposed to be releasing the package. I've left messages, I've sent email, I've even reached out on X and spoken with their social media team. And they all just keep referring me to a number that doesn't return my calls. So I gave up, and I made 2 more. I started with the 2 extra blanks, I milled them, I heat treated them, I ground them, I laser marked them, and that ended up being easily the most time-consuming part of the project. I shipped a new one via the US Postal Service and the Royal Mail, and it was delivered in less than a week with no drama at all. Will the FedEx package show up someday? Maybe. I don't know, but I'll think twice before using them again. In the meantime, I just got a package in the mail from Uri Tuchman, and if you are not familiar with his channel, join the club. I actually had never seen his channel before we did this collaboration, but I have been binging his videos over the last couple of days, and I gotta say, that man is an artist, and I mean that both as a compliment and as a description. The stuff that he makes is just amazing. I think my favorite thing that I've seen that he made was actually a nose picking machine, and it's something you just have to see to believe. But I got this package from him, and I am really curious to see what he made. Now, it did come with a very nice letter from Deutsche Post that says, following the air freight security and dangerous goods regulations, this parcel has been opened and inspected to determine the presence of forbidden contents. We found it unobjectionable. And I gotta say, if I were Deutsche Post, I would probably open packages from this man too. So, let's see what he sent. There's the pigeon. Is this hay? Smells like alfalfa. Also smells kind of like yerba mate. So I think that's alfalfa. Do you send a letter? Nope. A piece of hand-drawn art signed by Uri Tuchman himself. There's the upside-down pigeon. Morning oiler. And if I'm interpreting this correctly, we've got a puddle of oil sitting around an oiler with a brush. Looks almost like a stalk of asparagus, or maybe it's supposed to be covered in oil. That's amazing. Like I said, the man's an artist. Okay, got some oil brushes. And the handle. And yes, that is a stalk of asparagus. And do these fit? They do. That is amazing. Cloud 42 with the upside down pigeon. Looks like a sandwich with something spilling out. And it is indeed a little oil container. Oh, and this is set up so you can set it like on the edge. Set it on the edge of a desk and it looks like a pool of oil. Oh, this is amazing. That is gorgeous. Well, thank you, Uri. This is amazing. Definitely go check out his videos. This is just a small taste of the kind of stuff that he makes, and this is great. Okay, I just figured it out. It's a fried egg. So it's a fried egg sandwich for breakfast. It's a morning oiler. And looking at the hand-drawn artwork here, it's much more evident. It's an egg. I just didn't catch that the first time. Nice. And that, ladies and gentlemen, is Toolroom Takeover 2025. I'm reminded of a quote that appears often in the Kinetic Precision Discord. We do these things not because they are easy, but because we thought they would be easy. This project was a lot of fun, but it was also way more work than I anticipated, and I learned more than a few things along the way. Now that I think about it, maybe I should add scope creep to my resume. Here's a link to Uri's video so you can see how he made his gift for me, and here's a link to Chronova Engineering's video so you can see if my package really made it there intact. I'll also put up a link to the entire Toolroom Takeover 2025 playlist so you can watch them all. You really should. Thank you for watching.